In 1949, German cities looked like the surface of the moon. Millions of tons of rubble choked the streets, and the surviving heavy machinery was completely useless. Then, an orphaned combat engineer named Hans Liebherr brought one simple, obsessive idea back from the war. He designed a radically fast, self-erecting crane, but immediately hit a wall when broken supply chains couldn't deliver the precision parts. It should have been a death sentence. Instead, Hans refused to wait. He built his own factories and accidentally forged a $15.8 billion private fortress. Today, this closed-loop empire builds 1,200-ton Titans. It secures multi-billion-dollar mining contracts, and it dominates the global heavy iron world without taking a single cent of Wall Street money. Hans Liebherr was born in 1915, just as the Western Front turned into a meat grinder. His father didn't come home. Growing up an orphan, Hans learned masonry, carpentry, and how to keep a building standing before most kids left school. By the time the Wehrmacht drafted him into a pioneer battalion in 1941, he already knew how to read a structure and move material, working with what he had. He would need those skills to survive Rasputitsa, a brutal mud season the German army learned to fear. For a combat engineer like Hans, this wasn't an abstract problem solved on a map. The brutal environment burned one idea into his head. Heavy iron that can't move is just an expensive anchor. Lift capacity means nothing if a crane takes 3 days to set up and demands a concrete pad the size of a tennis court. When the terrain fights you, mobility wins. He carried that conviction out of the war and straight into the ruins of Germany. By 1949, German cities looked like the moon. Roughly 500 million cubic yards of broken brick, shattered concrete, and twisted rebar choked the streets. The workforce was gutted. The supply chain was dead. Worse, surviving heavy machinery was completely useless for the job. Cranes from outfits like Julius Wolf relied on thick steel cables wound through fixed pulleys. Crews spent 3 days sinking anchors, pouring footings, and rigging masts with secondary lifts. The bombed-out lots of Munich and Stuttgart lacked the solid ground those massive rigs demanded anyway. Hans looked at that bottleneck and drew up the TK-10, stamping the patent on August 19, 1949. The concept was offensively simple. Instead of heavy cast iron sections that required cranes just to build the crane, the TK-10 used a folding lattice mast of high tensile steel. A gravity-assisted pivot system let the machine self-erect. One truck haul, one crew. The rig went from flatbed to fully operational in 2 hours, obliterating the old multi-day setups. Small contractors finally had exactly what they needed to tackle thousands of scattered job sites. The TK-10 spread like wildfire because it solved a physical problem every crew bled over. Success brought a new problem. Hans hit the wall facing anyone building hardware in a bombed flat country. The parts weren't there. Specifically, he couldn't find the massive precision-cut slewing ring gears needed to let the crane rotate a full 360 degrees under load. Reliable sourcing vanished. Lead times stretched to months. When parts finally showed up, quality swung wildly. Hans's answer? Stop waiting. In 1952, he engineered his own gear-hobbing machines to cut precision gears in-house. Production ran on his schedule, locked to his exact metallurgical standards and microscopic tolerances. That decision formed the bedrock of the Liebherr empire. When the outside world failed to deliver, Hans built the capability himself. While the TK-10 dominated the skyline, Hans watched a similar failure play out in the dirt. Early 1950s excavators relied almost entirely on cable pull systems. A diesel engine wound a thick steel cable, yanking a bucket through an arc to drag and dump material. It worked, mostly. The digging force was wildly inconsistent because the cable tension doesn't stay linear against ground resistance. In hard clay or compacted fill, those machines ground to a miserable crawl. The line would slack, snap taut, and slack again. Buckets skipped across the surface instead of biting clean. Precision control of cut depth or angle was a joke. Hydraulics existed in 1953, but the industry used them in the laziest way possible. Tilting dump truck beds. Nobody had connected fluid cylinders directly to a digging arm to eliminate the cable entirely. Hans did exactly that with the L300, accidentally giving birth to Europe's very first fully hydraulic excavator. And he did it fast. Intolerant of slow development, He drove the project from concept to working prototype in 8 months. The L300 weighed just 16,500 pounds, roughly 8 tons, a quarter of the weight of the cable drag lines it replaced. Powering the whole rig was a dead reliable air-cooled Deutz diesel, barking out around 25 to 30 horsepower. It wasn't a massive engine, but with hydraulics you didn't need brute horsepower. You just needed consistent pump flow. Instead of winding a drum, the L300 relied on an early gear pump pushing hydraulic fluid at roughly 1500 psi. That pressurized fluid forced the cylinder open with a smooth, continuous stroke. Operators could hold the bucket at any angle and lock in the dig depth. The applied force never dropped off when the dirt pushed back. Hydraulics didn't care about soft sand versus hard-packed gravel. The physics were absolute. Ask any operator who ran drag lines before hydraulics took over. The difference was night and day. A fluid-driven arm bites dirt and holds. A cable system hesitates, skips, and snaps. When rebuilding a shattered continent, that leap in efficiency dictated exactly how fast you could clear a site and pour fresh concrete. By the mid-1950s, Liebherr had a lethal lineup. A self-erecting crane a small crew could rig before lunch. An excavator that actually dug instead of scratching the surface. An internal manufacturing base, immune to broken supply chains. Business exploded. The reconstruction boom across West Germany and soon the rest of a battered Europe kept order books packed tight. Construction is a viciously cyclical industry. The boom years ran fat and the lean years hit hard. When credit tightens and permits dry up, contractors stop buying new iron. They run the old fleet into the ground to survive. For a manufacturer needing cash flow to fund R&D, riding those cycles without a second revenue stream is dangerous. It's like running a diesel at redline with no oil pressure gauge. You might be fine for a bit, but by the time you hear the knock, the engine is already dead. Liebherr needed cash flowing during the cold years. He needed income completely detached from whether a Frankfurt contractor bought a crane that quarter. The answer Hans found had absolutely nothing to do with heavy machinery. By 1954, Hans turned his engineering brain toward a market far from the mud and diesel smoke of construction sites. The numbers made sense. Only 10% of German households owned a refrigerator. That left 90% of the country needing one. That demand wouldn't vanish the second the government slashed its infrastructure budget. When post-war reconstruction stalled in the early 50s, cash tightened. Every heavy iron builder in Europe felt the squeeze. Some begged outside investors. Others sold their souls to banks on a stack of loan papers. Hans walked away. Bankers pitched him an existing factory. His audit found slow production lines and overpriced parts, so he built his Oxenhausen plant from the dirt up, keeping a steel grip on every process. He looked at his floor, precision metalwork, tight tolerances, heavily sealed enclosures, and asked, what else needs to be built, dead nuts accurate, and stay freezing cold? Liebherr's appliance division launched in 1954. This wasn't a hobby. Liebherr's fridges held their seals, ran dead quiet, and didn't rot out after 2 winters. Buyers noticed. So did the margins. People buy fridges whether the economy is roaring or tanking. That steady year-round cash pumped straight back into the excavator division. That's a shadow profit engine. No public spin-offs, just a private cash generator keeping the shop lights on, the welders humming, and the forges hot, regardless of the construction market. Fridge money funded the next generation of hydraulic excavators. Those excavators won contracts, which built the next fridge factory. And appliances weren't his only accidental empire. When Liebherr expanded into rural Ireland in 1958, Hans dropped a tower crane factory right in the mud. He quickly hit a wall that had zero to do with hydraulics. His executives and clients had nowhere to sleep. Hans did what he always did. He built his own. In 1961, the Europe Hotel opened as a full-blown luxury resort right down the road. The logic mirrored the fridges. Strong occupancy prints steady money. Every room booked and steak served dumped cash right back into Liebherr's engineering pool. No stock ticker. In '67, he retooled that exact same Irish plant to build massive container cranes. Container shipping was brand new at that point. Most of the industry hadn't realized standardized steel boxes were about to choke out every port on Earth. Hans saw it. He put a crane factory in a field 20 miles from the water to build the machines that would sling those boxes. That's the pattern he ran since 1949. spot the bottleneck, build the heavy iron to crack it, and own the cash it kicks out. By the early 60s, Liebherr built something other machinery giants never attempted: a self-sustaining financial system. Iron funded appliances, appliances funded iron, and hotels plugged the gaps. The whole engine ran completely off the public grid. Caterpillar answered to shareholders. Komatsu answered to shareholders. Liebherr answered to Hans. That's not a minor detail. That's the whole ballgame when you're making 30-year bets on the future of heavy machinery. And you need that financial freedom because his next bet cost a fortune. Building bigger iron means you eventually hit the wall of what a third-party engine can handle. When you're designing a hydraulic system that needs to deliver a specific pressure curve and exact flow rates in GPM across a 180,000-pound machine, you can't just guess. Working at high altitude in sub-zero temperatures, you can't just bolt in whatever inline-six Cummins is selling and hope it plays nice. The engine and the hydraulic circuit have to lock in perfectly. In this business, leaving performance on the table means losing contracts. Hans saw that ceiling coming, and he started laying the groundwork for Liebherr's own legendary diesel blocks. He decided right then to build his own iron from the oil pan up. Most heavy industry builders never cast their own engines. Aside from Caterpillar, the industry standard is to call Cummins, sign a contract, and bolt in whatever fits. It's cheap, fast, and keeps the organization chart clean. Liebherr walked the other way. Hans Liebherr didn't start casting his own parts to save a buck. He did it because third-party foundries couldn't pour a slewing ring strong enough to keep his early cranes from snapping under a heavy load. Running a third-party diesel on your in-house hydraulics means you're always chasing a compromise. So Liebherr built their own. Their components division didn't just pour generic iron. They went after the full stack: block, injection, and the ECU tying it all together. When the guys writing the fuel delivery software sit across from the guys designing the hydraulic circuit, the system talks cleanly. No translation errors, no compromises from a supplier selling that exact same block to your rival. And it wasn't just the engines. By the 70s, they ripped the torque converters out of their crawler dozers entirely, swapping them for a closed-loop hydrostatic drive that gave the operator 100% power to both tracks, even in a dead pivot turn. The D9812 proves the concept. 2,700 horsepower out of a V12 diesel, purpose-built to sit deep inside Liebherr's biggest mining rigs and drag loads that would rip a third-party drivetrain to shreds. When you're swinging a 50 cubic yard bucket through granite all shift, the iron heart of that machine must be built to match. While digging deeper, Liebherr was also aiming way up. The aerospace division didn't appear out of thin air. It bled directly from their heavy hydraulics. It's exactly what slams landing gear down on a jet. Same physics, tighter tolerances. A blown line at 30,000 feet is deadlier than a ruptured hose in a rock quarry, but the core engineering logic translated perfectly. Their first real test? The 1960s F-104 Starfighter. Pilots called it the missile with a man in it, but the guys turning the wrenches on the flight line just called it the Widowmaker. When Liebherr integrated those hydraulics, there was zero margin. No second chances. Down in the dirt, a blown hydraulic pump just means a warranty claim and a pissed-off foreman. Up there, if the fuel bleeds out, the pilot dies. That program burned a zero-failure standard deep into the division's bones. Fast forward, they built the nose landing gear for the Airbus A380. That bird hits the tarmac at 170 miles per hour, slamming over 860,000 pounds of weight into the struts. On top of that, they engineered the folding wingtips for the Boeing 777X. That's 11 feet of wing on each side. Then, 1993 hit, and Hans Liebherr died. Instead of family infighting or a private equity buyout, his kids, Willy and Isolde, took the wheel. And instead of cashing out, they locked the gates and doubled down on the family iron. The second generation had already decentralized the group to Switzerland back in 1983. They built over 130 independent companies, each balancing its own books and holding total, unquestioned control over its own iron. Those subsidiaries act as watertight bulkheads. If one division takes a hit in a down market, the rest keep humming. By the mid-90s, Liebherr cast its own iron, wrote its own software, ran an aerospace division feeding the world's biggest jets, and funded every dime from internal cash flow. No bank owned them. No quarterly earnings call forced a cheap shortcut. That's not a company. That's a fortress. With that armor locked in, they turned their sights back to the dirt. The iron they were about to drop in the 2000s would push the absolute limits of what a machine can drag across the surface of the earth. Nine axles under a single crane carrier, all turning, all steering, picking through a Scottish Highlands dirt road that would make most haul truck drivers sweat through their shirts. This is the Liebherr LTM 11200-9.1. At 1,200 tons of maximum lift capacity, every inch of that road matters. Too soft to shoulder, and you're not calling a tow truck, you're calling a salvage crew. This was Liebherr in the 2000s. Forget modest job sites. They entered a world of extreme scale, where moving the iron from point A to point B was an engineering nightmare before a single load was swung. Two things drove this massive push, hitting at the exact same time. First, wind energy. In the early 2000s, turbine towers stretched past 260 feet. You can't rig that with a standard crane. You need a boom that clears the tower, a winch that doesn't flinch at 80 tons, and the footprint to hold that steel steady in open field crosswinds. To actually push 328 feet of steel into the sky, they use a single-cylinder telematic pinning system, mechanically locking each section into place to cut massive amounts of dead weight from the boom. The 11200-9.1's 328-foot boom handles the wind load with a Y-pattern hydraulic guying system. Massive cables keep the steel under constant compression so it won't buckle when the wind howls sideways. That's how you hold a full load at that height. Throwing a Y guying system on a telescopic boom isn't some standard rigging trick. It's the only way to keep 300 feet of steel from snapping like a toothpick when a heavy gust catches the load. And project managers quickly realized the 11200-9.1 needed 5 fewer truckloads to assemble on site than a crawler crane. On a rutted access road, 5 fewer heavy convoys saves days of grinding. Orders flooded in. Second, the global mining sector ran full throttle. Coal, iron, copper pulled at unprecedented volumes. Caterpillar had this world locked down. Their 793 and 797 haul trucks dominated every pit from Wyoming to Western Australia. Liebherr walked in anyway with the R9800 mining excavator, a 4,000 horsepower diesel beast swinging a 55 cubic yard bucket, weighing in at roughly 1.76 million pounds. That 4,000 horsepower figure doesn't happen by accident. They stuffed twin 60-liter Cummins QSK60 V16s in the back, screaming at wide open throttle just to keep the hydraulic pumps fed. That bucket tears 95 tons of rock out of the earth in a single pass. CAT operators knew their iron. Liebherr had to prove theirs could match it. In the freezing mud, over a full production shift, without nickel and diming the maintenance crew on parts. And Liebherr didn't just bring an excavator to the fight. In 2004, they rolled out the T282B haul truck, a 400-ton diesel-electric monster built to go toe-to-toe with CAT's best iron. But the physics of moving these titans on the road is worth a closer look. Moving the LTM 11200-9.1 over pavement means stripping it down. The boom, counterweights, and rigging travel on separate convoys. You've also got to factor in the counterweights. It takes over 440,000 pounds of stacked cast iron on the back of that rig just to keep the carrier from tipping when you swing an 80-ton nacelle. Yet, the bare carrier still drives enormous point loads through the axles. Liebherr's answer is the Nevomatic suspension. It's a live hydraulic loop where every axle talks to the rest, bleeding off pressure from a high spot and feeding it to a low one before a tire ever spins in the mud. It's constant pressure management, spreading the massive footprint so a heavy rig can creep down a narrow road without crushing the shoulder into gravel. Liebherr's been doing this since Hans built the L300 in 1953. Every axle steers independently. The carrier can crab steer sideways, pivot tight corners, and thread gaps that stop conventional transports cold. 9 axles, all active, facing a 14-foot gate. That's the difference between squeezing onto the pad or spending a week grading a new road. While they conquered the dirt, Liebherr ran a quiet empire on the water. As containerization reshaped global freight, Liebherr retooled their Irish plant to build massive ship-to-shore STS gantry cranes. By the time ships scaled up to Megamax vessels in the 2000s, Liebherr already owned the parts. Over the decades, Liebherr Container Cranes Ltd. Shipped hundreds of STS, rubber tire, and rail-mounted gantry cranes to 150 ports across 60 countries. Control the cranes at 150 ports, and you aren't just selling equipment. Every box moving from ship to truck on a Liebherr crane locks that port into Liebherr parts and service. Shut that down, and you don't just delay a ship, you choke the supply chain for an entire region. When you've spent decades proving your iron survives the worst the dirt, the grinding road, and the salt spray can throw at it, a certain confidence sets in on the engineering floor. The machines grew bigger, the specs pushed past what anyone would call practical. But scale carries its own brutal risks, and the iron doesn't care how confident you are when a lift goes south. Smartphone footage, shaky and raw. You hear the guys on the ground yelling before the iron even shifts. Then it goes. The massive lattice boom peels away from the vertical. The whole rig folds into itself. The groaning metal hits the mic a half a second late because physics doesn't wait for anybody. In 2013, a Liebherr LR11350 crawler went down during a lift in Brazil. And this wasn't some backwoods job site. This was the Arena Corinthians, rushing to stack structural steel for the World Cup under brutal, unforgiving deadline. The ground failed, not the crane, not the rigging, and not the operator. The soil profile under the pads couldn't carry the load. Once that support walked out from under 1,350 tons of rated capacity, the whole system crashed. Workers lost their lives. Liebherr didn't run from it, but they took a massive hit. Tens of millions evaporated, along with 30 years of hard-earned trust in the South American market. Fast forward to 2020, new footage surfaces. It's the Orion, carrying Liebherr's flagship HLC 295000, a towering beast rated to pick over 11 million pounds. This wasn't an active job out at sea, it was a shipyard load test, pulling against a barge to certify the rig, and the hook gave up the ghost halfway to the limit. A rigged load suddenly goes into free swing. The boom takes the shock, the system whips, and the structure eats a force it was never designed to handle. Kinetic whiplash. The third-party rope block hook snapped at roughly 2,860 tons, less than half its rated test weight. The vessel was brand spanking new, getting its deck violently ripped open before it even clocked its first day on the job. Investigators dug into every weld, pin, and load path. Forensics cleared the iron. The hook failed, not Liebherr's boom, not their hoist. A hook Liebherr didn't build, spec, or install snapped under dynamic load. This is exactly why Hans Liebherr spent decades refusing to buy critical components from outside suppliers. When a third-party part shatters on your machine, it's still your name painted on the boom. But while Liebherr could engineer their way out of a snapped hook, they couldn't engineer their way out of a war zone. Liebherr's roots in Russia go deep into the Cold War. They set up manufacturing inside the Soviet bloc decades ago. By February 2022, they weren't just exporting iron, they were embedded. Pulling out wasn't a switch you could just flip. Equipment, staff, and contracts were tangled in the mud. Competitors read the room fast. The suits at Cat and Deere suspended operations to protect their stock prices. Liebherr dragged their feet, prioritizing physical assets and their people. That put them dead in the crosshairs of government scrutiny and ugly press. Then it got worse. Under Article 9 of Federal Law No. 31FZ, corporate HR wasn't just asked nicely, they were legally forced to help the military push conscription papers. At Liebherr's Nizhny Novgorod plant, 37 workers were called in for medical exams. They never made it back to the floor. They got drafted. Liebherr eventually wound down their Russian operations, but the slow bleed cost them 70 years of credibility in the West. Their sovereign state philosophy slammed into a brick wall. No company operates in a vacuum when tanks start rolling. By 2023, the empire Hans scratched out of post-war rubble had taken two heavy blows. Physics proved soil reports matter as much as load charts. Geopolitics proved corporate independence has a hard ceiling. Both cost them tens of millions and deeply scarred a reputation they'd bled to build. Bruised and under the microscope, Liebherr's biggest threat was still looming. State-funded titans like Sony and XCMG were flooding the market with iron priced at levels no private German outfit could touch. The fossil fuel era that built Liebherr's empire was finally running out of road. Forget the diesel block. Battery matrices are rolling in. Hydrogen cells are bolting up where exhaust stacks used to sit. And every major player in heavy iron is scrambling to survive the next decade. Some will make it. Many won't. Liebherr walked into this fight holding an ace. 70 years of building every critical component in-house. When the specs changed, they didn't have to beg outside suppliers for a new parts list. China's XCMG isn't just a competitor. It's a state-funded operation wearing construction yellow. Beijing pumps cash into them like grease into a dry fifth wheel, constantly, ignoring the return timeline. XCMG can bleed money, flood the market with cheap iron, and wait you out. A family-owned shop from Buell, Switzerland doesn't look like a heavyweight for that fight. Liebherr didn't flinch. They ramped up R&D at a scale that would make most private boards choke on the invoice. Look at the L566H wheel loader. It runs on hydrogen combustion, not a fuel cell. Why combustion over battery? Torque. Hydrogen combustion holds the low-end torque curves and shock load resilience batteries still lack when you ram a bucket into a hard-packed pile or crawl up a steep grade. That's a mechanical call, not marketing. And Liebherr knows a zero-emission loader is useless in the outback if the nearest hydrogen tank is 400 miles away. They're engineering the fuel supply alongside the machine, just like Hans did in 1949. When he couldn't buy gear wheels, he built the machines to cut his own. On the electric side, watch the T264. It's a 240 metric ton class haul truck, packing a 264-ton payload with a gross vehicle weight pitting the scales at exactly 917,123 pounds. This isn't a concept, it's moving dirt right now. When one rolls into the bay, a robotic arm locks on and blasts 6 megawatts into the battery matrix. Because those electric wheel motors dump maximum torque at 0 RPM, that truck will haul 264 tons up a 10% grade faster than any diesel block could ever dream of. The R9400E electric mining excavator tackles power differently. The machine pulls hard grid power all shift, dragging a heavy tether loaded with a lethal 6600 volts without sweating battery life. It's grit independent. Copper doesn't care about the abrasive red dust. These machines exist because Liebherr already owned the heavy hydraulics, the control boards, and the structural steel. They didn't buy those capabilities, they just rewired what they already forged. Then Fortescue signed the deal. The ink actually dried in 2024, when Fortescue Metals locked in a $2.8 billion order for 475 zero-emissions machines, building the exact fleet that's tearing up the dirt in 2026. Read that again. $2.8 billion. That's no pilot program. That's a total fleet replacement at one of the biggest iron operations on Earth. They picked Liebherr. Not XCMG, not CAT, Liebherr. That contract answers the survival question fast. A family-owned company with no public shareholders, no quarterly earnings calls, and no Wall Street analysts demanding R&D cuts to pad the stock price went toe-to-toe with state-funded rivals. They walked away with the largest zero-emission mining contract in history. They pulled it off because of the foundation they poured in the 1980s. When Liebherr International set up in Buell, the goal was pushing decisions down to the trench level while locking financial control at the top. No outside investors, no board seats for sale. The suits answer to the family, and the family answers to the iron. The third generation held the line. They didn't cash out when the big money hit. They didn't go public when bankers showed up with slick projections, and they didn't strip mine their own divisions to fund outside buyouts. They poured the profits back into the machine, literally and operationally. Today, Liebherr runs over 140 subsidiaries across 50 countries, and every single one stays private. No IPO roadshows, no diluted equity, just pure control. There's a stubbornness to it, and I mean that as high praise. Stubbornness keeps a hydraulic line from blowing when the pressure spikes. You build it to hold. You spec it past the burst rating. You don't cut corners just because an accountant wants a better quarterly margin. That's how they build the machines, and that's how they built the company. At sunset in the Pilbara, a T264 will crest a haul road with 264 tons in the bed. It'll run on a massive battery matrix co-developed with Fortescue Zero, bringing F1 grade energy density to the dirt, controlled by software Liebherr wrote and riding on heavy steel Liebherr fabricated. 75 years in, and it's still a closed-loop system running hot. The third generation didn't cash out, didn't touch public money, and sure as hell didn't hand the keys to a bank. Jan Liebherr and Stephanie Wolfart took charge in 2023, and the family board still meets every 2 weeks to call the shots on an empire stretching from 400-ton haul trucks pounding the dirt right up to the high-rise tower cranes dominating European skylines. And yeah, they still make one hell of a kitchen fridge right alongside the 800-ton excavators. If you've turned grease-soaked wrenches on Liebherr iron, sound off below. Subscribe before you clock out, and we'll see you on the next one.